All right, let's talk about the single most manufactured object in all of human history. Seriously, it's not the wheel, it's not a brick, it's a tiny, tiny switch. And today, we're going to figure out how this little marvel is the secret ingredient inside basically everything you own. I know, it sounds like the beginning of a really terrible joke. But stick with me, because the answer to this question is, no joke, the key to understanding our entire digital age. Okay, so picture this. There's this super exclusive club, the hottest spot in town. We'll call it the Circuit. Inside, the party is, well, it's literally electric. It's where all the action happens. And like any hot club, there's a massive line of electrons snaking around the block. They're all just desperate to get inside and get the party started, to power your apps and send your messages. But there's a problem. The door is closed. And who's at the door? The bouncer, of course. But this isn't some huge, intimidating person. Nope. Meet the world's smallest, most efficient, and most reliable bouncer, the MOSFET. Its one and only job is to control the flow. Now, this bouncer is strict. You can't reason with it. It only responds to one thing, a specific signal coming through its earpiece. No signal, the door stays shut. The party's on hold. But the instant it gets the right signal, a specific voltage, that door swings open and the electrons rush in. And that, right there, is the essence of how a MOSFET works. So let's break this down. All right, let's just get the super technical name out of the way. MOSFET stands for Metal Oxide Semiconductor Field Effect Transistor. Yeah, it's a mouthful. You absolutely do not need to remember that. Just remember this. It's an electronic switch. A ridiculously tiny, incredibly fast switch that's controlled by voltage. So every one of these little bouncers has three parts. You've got the source, that's the entrance where the electrons are all lined up. You've got the drain, that's the dance floor where they all want to go. And then you have the most important part, the gate. That's the bouncer's earpiece. It's what gets the open or close signal. And here's the genius part. The gate controls the path, but almost no power goes to the gate. The bouncer just has to hear the command, not wrestle the door open. That efficiency is the whole secret. And these bouncers come in two main flavors. There's one called depletion mode, which is like a door that's always open, and you have to send a signal to close it. Kind of specialized. But the real star, the one that runs our world, is called enhancement mode. This one is normally off. The door is always shut until you give it the specific signal to open. And that simple idea, off by default, is the foundation of pretty much all modern computers. So the big question is, how does this door open without any moving parts? I mean, it's not a hinge. This is where the magic happens. It's not mechanical at all. It's just pure physics. Okay, so here's how the trick works. When there's no voltage on the gate, nothing happens. The path is blocked. But as soon as you apply a small positive voltage, that creates an electric field, and that's the field effect part of its crazy name. This field reaches down into the silicon and actually pulls negatively charged electrons up towards the surface. Get enough of them together and they form a tiny temporary bridge, a conductive channel, and poof, the bridge exists, the switch is now closed and current can flow. The moment you take the voltage away, the bridge vanishes. It's incredible. And this is the real game changer. It's controlled by voltage, not current. See, older transistors needed a constant trickle of current to stay on, which wasted a ton of energy. That's like paying the bouncer every single second just to hold the door open. A MOSFET is way smarter. It just needs to see the voltage signal. This makes it absurdly power efficient. And that's exactly why we can have powerful computers that run on batteries. Okay, so we've got a tiny, efficient switch. Big deal, right? Why does this one little component matter so much? Well, because it has a combination of superpowers that changed everything. One, they're unbelievably fast, switching on and off billions of times a second. Two, they're super efficient, which is why your phone battery lasts all day. Three, you can shrink them down to an atomic scale. And four, they're stable, so you can pack them tightly together without everything melting. You put those four things together and you have the perfect recipe for a technological revolution. And I really need you to understand the scale we're talking about. Your phone's processor doesn't have a few of these, or even a few thousand. It has billions of these tiny little bouncers on a chip smaller than your fingernail, all opening and closing their doors in a perfectly synchronized ballet to run your apps. And that's not an exaggeration. Seriously, every single calculation, every piece of information stored in memory, every pixel that lights up on your screen, all of it is just the result of these simple on-off switches working together on a scale that's almost impossible to imagine. Here it is. The next time you tap your phone screen, just remember what you're actually doing. You're not just opening an app. You are the commander-in-chief of an army of billions. You're issuing an order to a whole city of microscopic bouncers, telling them exactly which doors to open and which to close, all just to make a cat video appear on your screen. The MOSFET is the true unsung hero of the modern age. It's the simple, elegant, fundamental building block that makes our entire reality work. It's the atom of the digital universe, and it just proves that sometimes the absolute smallest things are the ones that change the world.